So far our cube has been moved by typing in values in the transform panel location, XYZ values. This allows for precise positioning. There's another way to move an object freehand. Up here in the top left, there are three icons: move, rotate and scale. Each one has a shortcut key as well. Select your object, if not already, with a left mouse click. Now select the move icon. Three coloured arrows appear in the centre of the object. Left mouse click on the green arrow and hold down. Move your mouse. Notice how your object moves along the Y-axis. Look also at the values changing in the transform location panel. Now repeat with the blue and red arrows. The quickest way to move the object whilst the move icon is selected is to place the mouse pointer within the white circle. Hold down the left mouse button and move your mouse around. Don't forget, you are freehanding the position to an approximate location. You would still need to type in values for the X, Y and Z to be accurate. Type 0 in or hover the mouse over the values and hit the backspace button to get back to starting values. Now click the rotate icon top left. Similar to the move icon, it rotates the object on each axis. Lastly, select the scale icon. Here you can adjust the scale along each axis. Notice how the dimensions and scale values change. We can't create a new world without adding new objects. To do this, select Add in the top left. The text Shortcut Shift-A appears, informing you of another way to select it. From the drop-down, you are presented with a cupboard full of goodies. Given what we've just learnt, we can start to make a llama. I have dimensioned the llama, and you can see the insets as we proceed. First, we'll change the units from metres to millimetres. Select Scene Properties, Units and change in the length drop down. Now we'll make the cube into the llama's torso. Its x-axis length is 50 millimeters, y-axis length is 40 millimeters, and z-axis length is 35 millimeters. Type these values into the dimensions values. Get used to your orientation. Look at the gizmo top right. For a better understanding of the XYZ concept, rotate your object so that the red balloon is pointing left, the green Y-axis is pointing at you, and the blue Z-axis is pointing vertically. I'm now going to make all the components by selecting Add or Shift-A, then Mesh, then Cube or Cylinder, and then duplicate with Shift-D as required. We need to raise the torso relative to the grid XY. The distance between the ground and the centre of the torso is 54.5 millimeters. Enter that value into location Z value. I'll fast forward the video while I create all the other components. Now previously I got this far and then started to try and snap connect all the components precisely. I say tried because in standard Blender you can only get components to connect and align, sort of, but not 100%. Blender does have a snap function allegedly, but my trials of it proved very hit and miss. Out of frustration, I walked away, but later in the day, after a bit of Googling, I discovered that there is a free add-on to solve this dilemma. It's called CAD Transform for Blender. Okay, I thought, I'll persevere, and I think it's a worthwhile add-on. Before proceeding any further, go to the link in the description and download it. You might consider making a donation to the creator. Once downloaded, open Edit, then Preferences, Add-ons, then Install. Find the file in your downloads called slcad transform 091.0.zip. Select it and click Install Add-on. Once done, tick the box adjacent to the file. There are several YouTube tutorials on installing and using the add-on. Here on the left you get a new icon. A new tool set appears up here, and on the right you get a list of shortcut keys and combinations. Now we primarily need this add-on for precise position snapping between two components, like the leg to the torso. The drawing insets will guide you on which bit goes where. Select a leg with the left mouse. Press the G key. Hover the crosshairs over the edge junctions. A circle appears on the left-hand corner. Press and hold the left mouse button, then move the corner to the torso corner. Release the button and click again to confirm the snap. Repeat the procedure for the other legs. Orientate your viewport to get a better sight of your target. If you stuff up, hit the Escape key and press the G key again and retry. Now we'll tackle the llama's ankles. These are not a corner edge to corner edge snap. One edge lines up with the inside of the leg edge but centered, so no vertices align. We need to snap the ankle edge center to the edge center of the leg. After selecting your ankle with the left mouse button pointer, press the G key, then the Shift E keys together. Now when you hover the mouse over the ankle edge, a midpoint appears. Grab and hold down on that. Move the ankle to the leg where the inside edge center of the leg will appear. Release and re-click the left mouse button to confirm the snap. Now for the feet. No center edge shortcut required here, as the foot corner aligns with the ankle corner. Now the tail. It's a center edge to center edge of the rear torso snap, so the Shift E key is required after the G key. Similarly for the llama's neck. Center of the bottom edge to the center of the torso bottom edge. Time for the ears. After a bit of repositioning in the viewport, they snap bottom corner to top rear corner of the neck. For the rest of the components, we'll use the add-on to get the faces to snap together. Then use the X, Y, Z location values to position precisely. Just get the face to snap to the face of the neck. Orientate the model to look straight on. From the inset, calculate the X, Y, Z position of the face and enter those values into the transform panel location values. The mouth is easier. It snaps to the bottom of the face. The nose needs to be rotated 90 degrees first. If you've been amending XYZ values in the transform panel, you will need to switch the add-on icon on again. Now the 4 eye components all need rotating by 90 degrees. Highlight an edge of the cylinder and then snap to the side of the neck edge. There, all done, just like a Lego llama, every component precisely located. In an artistic way, you could have made shapes, slapping them on, resizing and repositioning as you go. Nothing wrong with that approach and how a lot of Blender models are made.